A very warm afternoon, ladies and gentlemen. Welcome to the monthly technical session of SB Abuja section. It's a pleasure to have you here. We kindly appeal that you share the link to your colleagues because we are pleased to have Engineer Agbula Olayinka, PhD, a lead engineering and standards as tailing oil exploration, who would do justice to today's event. So please kindly invite your colleagues, your friends to be part of the technical session. Okay, once again, a very, very warm evening, ladies and gentlemen. Welcome to our September monthly technical meeting. The Society of Petroleum Engineers is an organization where we share technical knowledge to those working in the oil and gas industry. Every month in SB Abuja section, we pick a very exciting topic and share with all of our members. So you are very, very lucky to be part of today's monthly technical meeting, which is on the theme pipelines and storage tanks. Siamese twin in the oil and gas sector. Today, we are pleased to have the lead of engineering and standards of Sterling Oil Exploration and Energy Production Company Limited, Engineer Bola Olayinka, PhD, who, of course, will do justice to the topic. Please confirm you can hear me. And if you can hear me, kindly head over to the chat box and let us know where you are joining us from. Kindly head over to the chat box if you can hear me. I would like to know where you are joining us from. Head over to the chat box. Let's know which parts of the world, which part of Nigeria, which part of Africa you are joining us from. While you attend, on your screen is the order of events for today. Of course, the event is built to last for an hour and 30 minutes. After the arrival, which you are still awaiting your arrival, we'll have a safety brief, and then we'll introduce and recognize our guests on the call. Then we'll have a welcome remark by our section chair. We switch gears immediately to knowing our moderator, who will highlight the biography of the speaker. And then we have the lecture, which will last for about 30 minutes. After the lecture, you have the opportunity to ask him questions for 15 minutes, and then we switch gears to the closing remark, and we are done for today. My name is Ofo Fonono. My pleasure it is to serve as your moderator for today. Of course, let me continue the event by sharing a few safety brief or some housekeeping rules for today's event. Please, we appeal that you mute your mic if you're not speaking, so I don't cause interference during our deliberations today. We also appeal, please, for the course of the event, that you raise your hands if you want to speak, or you use the chat box for comments and questions. We also appeal that you ensure you can hear the fire alarm with your headset, and be alert and aware of your environment. Let me head over to the chat box and see those that have dropped comments, and then we continue by recognizing some amazing guests on the call today. Okay, I can see Ikechukwu Okafor at Section Chair joining from Lagos, Nigeria. Pleased to have you on the call, sir. We have Olainka Agbola, our speaker, joining from Abuja, Nigeria. Salim Madawaki is joining from Lagos, Nigeria. Kafayat Adeyemi is joining from Abuja. Emmanuel Obuye is joining from Abuja. I like that. So we are struggling between Abuja and Lagos, competing for the highest numbers. We have Joshua Ekpo Badaru joining from Lagos, Nigeria. Beatrice AJ Abuja. Inos BKS is hearing me from Chad. Amazing. Our first international audience. Thank you, Inos BKS, for joining us from Chad. We also have Dijo from Abuja. Dijo Lawrence, thank you for joining. Ladies and gentlemen, let me continue by recognizing some amazing guests on the call. First of all, we say a warm welcome to our leader, the man in charge of the section, the leading light in SP Abuja section, Engineer Ikechukwu Okafor, PhD, our section chair. A very warm evening to you, sir. Section chair, can you hear me? I'm greeting you, sir. Okay.
Akman, I can hear you. I was trying to unmute. Good evening, and good evening, everybody on the call. Good to be here.
Thank you. How is Lagos today, sir?
Well, it's good. I just got back after I just finished the training session.
Awesome. Thank you, sir, and welcome to the call. We also have on the call the program's chair of SP Abuja section, Professor Kafayat Adeyemi. A very warm evening to you, ma'am.
Good evening, Akpan. Good evening, everyone. Good to be here. Welcome, our facilitator. Good evening.
Thank you. Of course, the facilitator, the man who is will be speaking today for the next 30 minutes, Engineer Agbola Olayinka, the lead engineering and standards of Sterling Oil Exploration and Energy Production Company Limited. A very warm evening to you, sir, Engineer Agbola Olayinka.
Good evening, sir. Good evening to everyone, the program chair and everyone on call. Good evening.
Evening. Welcome all of our professional members on the call. I can see our Assistant Diversity and Inclusion Chair, Engineer Oken Wakwo. Welcome, sir. Pleased to have you on call.
Yeah, good evening all. Good evening, section chair. Good evening, program chair. Good evening, the facilitator. Thank you very much.
Okay, thank you. Ladies and gentlemen, let's switch gears to the reason why we are here. But before we do that, we'd like to hear from the leader of the section. Please help me welcome for his remarks, the section chair of SP Abuja, Engineer Ikechukwu Okafor, PhD. Over to you, sir, for your welcome address, sir.
Pastor Fan, you can hear me.
Loud and clear, sir. I hear you.
Okay, thank you. Good evening, everyone. Today we are here to listen to a guest speaker on the SP Abuja section monthly technical meeting, and we were talking around pipeline and storage of oil, a critical infrastructure that supports our drive to become an energy secure country. It's critical because we need to ensure there is availability, affordability of our food oil. And so I want to welcome everyone on behalf of the SP Abuja board to the September monthly technical meeting. It's good to have us on this call. And to our speaker, thank you for accepting to speak to us, to share your knowledge base with us in advancement of the SP core value of sharing technical information around the oil and gas industry. We are pleased to have you, and we believe in no long time you would give us value for our time, taking us through your experience and sharing knowledge with us. On behalf of everyone from the council chair who has just joined and to the board of SC Abuja section, we say welcome and let's have an amazing time listening to our dear speaker. Good evening.
Thank you so much, Section Chair, for that remarks. Thank you so much. Of course, we are so excited to hear on this very interesting topic, twins in the oil and gas industry. Of course, our speaker today, ladies and gentlemen, is Engineer Agbola Olainka, a seasoned mechanical engineer with a cumulative industrial and academic experience spanning about 15 years. He obtained his BTech in 2018, or beg your pardon, 2008 from Ladoke Akintola University of Technology, Lautech, Obomoso. He then proceeded to the Federal University of Technology, Akure, Futa, to earn MEng and PhD from the Department of Mechanical Engineering in the year 2014 and 2021, respectively. His experience in the oil sector spans from the upstream sector through the midstream to downstream sector of the oil industry. His business for construction, inspection, and testing made him to pursue career in pipeline engineering and storage facilities. He has acquired some international certifications, which include API 1169 Pipeline Construction Inspector, ASNT NDT Level 2, UTRT MT PTVT, Process Piping and Pipeline Design. He is a Korean registered engineer, a fellow of the Nigerian Society of Engineers, and of course, a corporate member of the Nigerian Institute of Mechanical Engineers. He is the founder and the managing director of Omega Joy Limited and Omega Hub of Piping and Pipeline Engineering Limited. The companies are founded to provide engineering services, consultancy services, training services, inspection, and testing services. Of course, he is married to Beatrice Agbula, and the union is blessed with wonderful children. Ladies and gentlemen, help me welcome for the next few minutes, the next 30 minutes, the lead engineering and standard Sterling Oil Exploration and Energy Production Company Limited, Engineer Agbola Olainka, PhD. Over to you, sir. Please take us and blow our minds.
Thank you so much, the program moderator. Without wasting time, let me quickly go to share my screen. Okay. Okay, can you please confirm that you can see my screen?
Yes, please, but we are not seeing your face well enough. Probably you could adjust your laptop lower so that we can see your face. Good, awesome. Thank you, sir.
Okay, thank you. Okay, so like I said, I don't want to waste our time because I know that I only have 30 minutes. But notwithstanding, I would like to acknowledge the leadership of SPE Abuja section, ably led by the section chairman and other part of the leadership. I also want to recognize the program moderator here, Engineer Fonono. Sorry if I don't call your name correctly. So, without wasting much of our time, we are looking at the topic pipeline and storage tanks, a Siamese twins in the oil and gas sector. And if at any point in time you cannot hear me clearly, please let me know so that I can. So whenever I have opportunity to present to the gathering of intellectual people like this, I always be careful and always like to acknowledge three set of people, three categories of people here. The first category are the people that know far more than I do. So this category of people want to crave their indulgence to bear with me and also just accept me the way I present it. Then the second category will be the people that we are at par, that we're on the same level. Your positive criticism also is welcome. And the last category of people here is those people that maybe they are still coming up. I also want to encourage those category of people to try and buckle up. And if there's any question that is not clear to them, anything that is not clear to them, they are free to ask question at any point in time. So having said that, I want to quickly go into the presentation proper. So this is the highlight of the presentation, and confirm that you can see that screen. So we are going to quickly look at introduction, the significance of pipeline and storage system, statistical facts about pipeline and storage times, historical background, down to standard codes for oil storage tanks, then the regulatory requirements for both pipelines and the storage tanks. I hope you can hear me.
Yes, we can. We can hear you.
Okay,
Hear you
thank
properly.
you, sir. Okay, so as a way of introduction, we have been hearing pipeline. What is pipeline all about? If you look at the picture to the right side of the screen, we can see that pipeline, we can see storage tanks. So pipeline is nothing but a network of pipes, that is pipes that are being joined together for one purpose. What is the purpose of pipeline? Just to transport fluid. And as we all know, fluid is oil. It can be fluid, generally is either gas or liquid. So which is either gas or liquid. So as far as oil and gas industry is concerned, the pipeline that we are looking at is the one that can carry either oil, gas, or water over long distances through different terrain and environments. By the time we go further, we will understand better. Then the storage tanks, on the other hand, is the container purposely designed to hold fluid. So that's why we said there's no way they are like Siamese twins. There's no way you will talk about pipeline and you will not talk about storage tanks. So they go hand in hand. They are like conjoined twins, Siamese joined together. And if you check the go back, so as you can see from this drawing here, from this picture, we can see these twins joined together by their shoulder. So one is pipeline, the other one is storage tanks. So that's what we mean by Siamese twins in the oil and gas sector, because whenever you talk about pipeline, we also talk about storage. So now the importance of pipeline and storage cannot be overemphasized because it's cut across upstream sector, which has to do with exploration, development, and production, and also the midstream sector, down to the downstream sector. So there's all these three sectors of oil and gas: upstream, midstream, and downstream. These three, you must talk about pipeline and also talk about storage. So that is why the importance of pipeline and storage system cannot be overemphasized. So as important as these two things are important, so we must try as much as possible to design it with a relevant standards so as to function safely and effectively. Those two keywords. Whenever pipeline and storage system are being designed, it must be designed in a way to function effectively, to be able to do the work that is meant for, and also to work safely so that there will not be any form of explosion, leakages, and the likes. So now, still talking about the significance of pipeline and storage tanks. Our pipeline can be seen as let's look at it in a way like a circulatory system, human body, human system. Some of us that did the biology in the secondary school, we know something about circulatory system. And we want to now relate it with oil and gas sector. One thing I appreciate most in engineering and in science is that, everything that we are inventing in engineering or science is trying to do, that scientists are trying to do, has to be like a creative ability that God has deposited in us. Everything that we are trying to invent is to mimic the creative nature of our maker, which is God. So now, in the oil and gas sector now, let's look at this circulatory system. I said pipeline and the storage tanks can be likened to our own circulatory system. For pipeline and storage, you must need pump, either to pump into the tank or to pump away, either for discharge or to receive. So the same way our heart is pumping blood, which is in oil and gas can be oil, it can be water. So the same way pump is working, so is the human heart. So pump is analogous to human heart. Then also the pipeline is also equivalent to arteries and veins, which we call blood vessels, that is taking bloodstream from one region of organ to the other. Then the storage tanks in this sense is also equivalent to various organs. You pump blood and to make the blood to complete the circulatory system that we have in human system. Okay, so we are looking at the statistical facts about pipeline and storage. And the first one, according to NUPRC, which is the Nigeria Upstream Petroleum Regulatory Commission, this was obtained from the website. They said there are 323 developed fields in Nigeria, that is in upstream. And then these fields are connected to 265 processing facilities. Okay. So, and then the stabilized oil and gas are exported via 31 export terminals. So export terminals has to be connected maybe to a pipeline, or some people are using barges to do the operation. Then the onshore processing infrastructure are linked to 8 crude oil or condensates NGL exports terminals. Okay. So altogether, the total in Nigeria, we have about 5,285 kilometers of pipeline. Also, as at Q1 2023, the quarter one of 2023, what we have is about 3,200 kilometers of gas pipeline in Nigeria. So, and then the current one that everybody should be aware of is 40-inch by 614 kilometer AKK pipeline, which is Ajakuta Kaduna Kano pipeline. Then also the 48-inch, which was later reduced to 48-inch, reduced to 36-inch by 130 kilometer pipeline, which is OB3 Obricom. So this information was obtained from Upstream Gazette 2025. Now, globally, so we can see the importance of the pipeline even in the Nigerian sector. And if we are going to look at it in a broader view globally, pipeline accounts for about 71% of petroleum transportation. And that is why they would always say that the safest and the efficient way of transporting petroleum products is through pipeline. Other alternative means can also be explored, but the acceptable one is through pipeline transportation. Trucking can be used where pipeline may not be too feasible. Then the barging also can be used, but the acceptable one is pipeline transportation. And we are going to look at some of these global pipeline. The first on the list here is Druzhba pipeline, which is about 4,000 kilometer laid from Russia down to Central Europe. And the pipeline has capacity of taking 1.2 to 1.4 million barrels of oil per day. Can you imagine transporting this quantity of 1.2 million barrels of oil per day? Then the second one is ESPO pipeline. The length of that pipeline is 4,857 kilometers, and the pipeline is laid from Russia to China and also capable of delivering 1 million barrels of oil per day. So BOPD. Okay, so quickly, this third one, Nord Stream 1 and 2, is also from Russia, and the length is 1,224 kilometers. But this one, because of the ongoing issue, so Nord Stream 1 and 2 is not operational at the moment. Then the Keystone pipeline system, which is about 3,380 kilometers, is to carry oil, 590,000 barrels of oil per day from Canada to the US. Look at it, like 9 of them. Then the last on the list here is the one from China to Myanmar oil and gas pipeline, which is 800 kilometers, and is capable of delivering 440,000 barrels of oil per day. So this information was obtained from Ghana Upstream Petroleum Chamber, as published in 2024. Now, as we have seen that pipeline across the globe, but in all this, US has the highest span of the pipeline than any other country. For gas alone, they have 1.9 million kilometers, 1.9 million kilometers for gas, and for oil, to receive petroleum products, is ranging 240,711 kilometers. So following United States is Russia and Canada. They are second and third respectively, and they have total length of 163,000 and 100,000 kilometers respectively. And this information can be seen from Wendy 2018. Okay, so I move on. So we are trying to lay this foundation so that we can understand the importance of the pipeline and storage before we go into details. Then a major breakthrough in the oil and gas, the notable ones are from the historical background. We have Trans-Arabian pipeline, which we call pipeline. The length is 1,930 kilometer pipeline, which was completed in 1950. So that is when the pipeline issue started coming up. Then they moved. With the emergence of technology, Alaska pipeline also was completed in 1977, which is to transport oil from Alaska North Slope to farthest in Alaska. And these days now, we now see different kind of pipeline cutting across different parts of the world. Even there is one that I think Nigerian government is planning that will go all the way from Nigeria down to Morocco. So that shows the importance of transporting petroleum products through the pipeline. Okay, now to some of our listeners that maybe they are not really into this field, or our young graduates, it might be confusing, because I also had that issue when I was an undergraduate. I didn't really know the difference between piping system and the pipeline system. That once I just see a network of pipes, what comes to my mind is either piping or pipeline. I didn't really know the difference until later. So because of to cater for this set of people, that's why we are trying to give the similarity as well as the differences between piping and pipeline system. So now, either piping or pipeline system, the one thing is common among them. They make use of pipes, which we call line pipes. So line pipes are joined together. So whether it is piping system or pipeline system, pipe must be there. Then there will be presence of valves, fittings, and then either piping or pipeline, they are to transport fluid. But the difference will now be the length of transportation. If it is within a short span, maybe within the battery limits, that one is piping. As we can see from this, second picture here, this one we have connection of pipes connected together. This one is piping system, while the upper one is a pipeline system. Then on pipeline system, you have few equipment on it. You can only have few equipment and it spans for a very long distance. You only have few equipment on it. But for piping system, you see so many equipment on them, both rotating equipment and non-rotating equipment. Then the next one is consideration is given to terrain. When you are talking about pipeline system, you look at terrain, whether it is slopy, you look at the environment and the likes. But for the piping, you are confined to a small space, and mostly you like a process piping, but pipeline system has to do with a long distance. Okay, so we move on to classification of pipelines. How do we classify pipelines? We use different criteria to classify pipeline. We can, based on location, we have onshore pipeline and offshore pipeline. Onshore pipeline is the one located on the land, while the offshores are the one underwater in the sea, just outside the land. It's called an offshore line. If our classification is to be based on the operating condition, then we look at high pressure pipeline and low pressure pipeline. Then if you are looking at the function that we are using it for, then we can classify them into gathering pipelines. We can classify it to transmission pipelines and then distribution pipeline. Then lastly, if the classification is to be based on products, then we talk about oil pipeline, we talk about gas pipeline in the product pipeline. Okay, so now we have talked about the pipelines. The pipeline is not something, because one of the highly regulated industry all over the world, even in Nigeria, is oil and gas sector. So one cannot just wake up, a company cannot just wake up, or an individual cannot just wake up and say, I want to lay a pipeline from point A to point B, or to lay export pipeline from one location to the to export terminal. No, it is not done. So the pipeline is regulated, let me speak about Nigeria now, if it is upstream pipeline, it will come under NUPRC, Nigeria Upstream Petroleum Regulatory Commission. And if it is the downstream pipeline, that one will come under Nigeria Midstream and Downstream Regulatory Authority. Then another agency that's I omitted by mistake is a Federal Ministry of Environment. They are also involved, because anything that you are doing that will impact the environment, the Ministry of Environment has to be carried along. So before the pipeline, before a pipe is laid, there are some regulatory requirements that must be met before we can go ahead to lay any pipeline. So that I classified into two, as approval of permit relating to pipeline routes and construction. Those things that you need that has to do with pipeline route and the construction. Then the second approval is classified as approval relating to engineering of pipeline system. So under the first category, we have permit to survey. You get this one from either NUPRC or NMDPR, depending on the kind of pipeline, whether it is upstream pipeline or downstream pipeline. So permit to survey is to get the route that the company has selected, that okay, this is where I want my pipeline to go through. So we need to do the permit to survey. Then from there, after you do the survey, you come back and then do the conceptual and field approval. Then you move to detail engineering design. Then there is another one, permit to construct, which is oil pipeline license, OPL, that must also be obtained. It is after you have gotten OPL that you can now proceed to do any other one, which is the field approval, detail engineering design approval. Then you now notify the regulatory authority when the actual construction is starting. Then after the completion of the construction, the next step will be the commissioning and commissioning with approval to introduce hydrocarbon. You can't just say, okay, I've constructed the line and I want to use this. The same regulatory body will still come and check. And then during the course of the project execution, maybe a project rep will also be assigned to that project that will be monitoring and be the eyes of the regulators in the project. Then the last one will now be license to operate. So after passing through all these approval gates, then the regulatory authority or the regulatory commission, depending, will now issue license to operate the pipeline, which will be renewed annually at the payment of some statutory fee. So this flow chart is showing the process for getting the permit to survey. And then the other one is also showing the left one is showing the flow chart for the PTS, while the one at the right hand side is showing the flow chart for obtaining oil pipeline license. Because of our time, I may not be able to go into details, but maybe by the approval of the leadership of SP Abuja section, maybe we can share the PPT slide. Okay, so in the design of the pipeline, there are some relevant standards and codes that must be followed. Number one there is power piping, which is not relevant to this discussion. That one is ASME B31.1. Then the second one is the ASME B31.3, which is a process piping. That one is for piping. Then the last two, which is ASME B31.4, pipeline transportation system for liquids and slurry. This one is relevant to our discussion today. And the last one, gas transmission and distribution piping system. So these codes are very important that at the design stage, the designer must be familiar and design it to ensure that there is no failure. Okay, so after the design stage, the next thing is, after we have succeeded in designing and our design has been approved by the relevant authority, then the next thing is to go into pre-construction and construction activities. So we are dividing it into pre-construction activities, construction activities, and then post-construction. For the pre-construction activities, like as I said earlier, I said route selection. You select the routes that you want the pipeline to go through, taking into consideration the environmental effects, the social. Maybe if you discover that where you want your pipeline to go through, maybe it will be going through museum, or it will go through people's houses and there will be so much demolition. So the pipeline might be rerouted to another node to cause so much havoc. So route selection is so important. Then the second is the permitting. As I said earlier, you get the necessary approvals before we go on to do the construction activities. Then the third one, as part of the construction activities, land acquisition. There's something we call a right of way. The route that the pipeline will go through, we have to acquire some right of way, which can be minimum of 10 meters and as high as 50 meter, depending on the diameter of the pipeline and the importance of the pipeline. If it is gas pipeline, you give more room for right of way than the oil pipeline. Then the last one is a design, that the pipeline must be designed with the relevant codes and standard. Right material must be selected. Then the appropriate wall thickness, which is schedule number, must be also be adhered to. For oil, the schedule can be 60 to 80, schedule 80, 60 to schedule 40. And for the gas pipeline, should be minimum of schedule 80 and above. So, okay, so for the construction activities, I will, so for people that we do maybe that are already into construction of pipeline, they will understand better, which is the number one on the list will be clearing and grading. The parts that the route of the pipeline must be cleared and graded to remove any form of hindrances. This is the clearing and grading. Then the trenching is to make the hole. This is the picture for trenching. Next one is stringing. Stringing of pipeline means just to arrange the pipeline along the trench. Then the welding, which is joining of the pipeline segments. Pipe can be 20 feet, it can be 40. Then the next step will be coating and wrapping of the welding joints. Then followed by lowering it. That is lowering of the well of all the pipeline that has been joined together. Then the backfilling, which is to fill the trench with soil and cover it up, then restore it to as met condition. Okay, so some of those steps that I mentioned earlier, this is stringing, arranging the pipeline along the trench portion, and this is the welding going on here. This is the coating and wrapping of the pipe that has been welded. Then this is the lowering in, putting it into the trench. Then the picture for backfilling is not here. So this is the picture of the construction activities. Okay, so after the construction, the last category is the post-construction activities and quality control. Part of the hydro testing is to test the pipeline. Usually, we have the one that we use water is hydrostatic testing, and if it is which people call the actual name is pressure testing and can be done with water. If it is done with water, which is the preferred one, is hydrostatic testing. And if it is done with air, under air, we call it pneumatic testing. The purpose is to check the integrity of the pipe and the welding joints to see that they can withstand the pressure. So usually the pressure test can be 1.25 multiplied by allowable operating pressure to 1.5. Some people may use 1.1, some 1.25 multiplied by the maximum allowable operating pressure, and some people can use maximum of 1.5. So for the gas pipeline, the allowable one is 1.5 to be multiplied by the MAOP. Then the removal of the air and water from the pipeline, which is known as purging. The purging of the pipeline is part of the post-construction activities. Then the final inspection of everything before the pipeline is being put to use. So part of the quality control, quality control has to start from the cradle to the grave, from the beginning to the end, which is the material inspection. The pipeline, before you even begin to trench, before you begin to do trenching, the pipe itself, the line pipe must be inspected for defect or damage. Anyone that you have any form of defect or damage on it should be rejected immediately. Then the welding inspection. In this one, there are some specialized people that their own work is, they call them, they're like the certification they call CWI, Certified Welding Inspector. So it's a profession on its own, like people are trained to do welding, to inspect. And these are the people that always be qualified welders that will do the welding on the pipeline, not just any roadside welder that will do the welding. Then the last one is coating inspection, which is the holiday inspection or holiday test to inspect coating for any leakage or any defects. Okay, so now what are the statutory maintenance operations required on the pipeline? Apart from the inspection that will be done by the facility owner, the company in this case, there are some statutory maintenance that the regulators also looking for, that they always ask for the evidence, maybe on yearly basis or maybe once in 2 years. Number one is pipeline route surveillance. They always ask for this statutory maintenance. How do you safeguard the pipeline right of way and the routine surveillance to ensure that the pipeline is safe and it's not causing any problem to the community where it's transversing or where the pipeline is going through, to ensure that underwater pipeline, maybe there's no any leakage that can affect the aquatic life. Then the another statutory maintenance operation expected by the regulator is corrosion monitoring, to see that there is no corrosion. Like some people will say, corrosion is corruption. As far as oil and gas is concerned, corrosion is corruption, and corruption of any kind is not allowed, so that there will not be failure of equipment. So part of this is cathodic protection system, which can be cathodic protection, which can be sacrificial anode or impressed current. Anyone that is suitable can be installed. Then that is for external corrosion from the soil to the outer section of the pipe. But what about the inside of the tank? How do you minimize or monitor the corrosion? You can use a pigging, intelligent pigging, to check what is going on within maybe as a result of erosion of the materials. So these are the two statutory operations required. Then on the pipeline, we also look at, finally, we are looking at decommissioning and abandonment for the pipeline. That after you design the pipeline for maybe 20 to 25 years or maximum 30 years, but actually it's supposed to be 20 years. Now, after outliving its useful lifespan, you don't just leave the pipeline and allow it to you leave it in the ground, and then you assume that everything is okay. It has to be decommissioned and abandoned in the proper way. And this particular topic is not taken lightly by the regulator any longer. So part of the commissioning procedure is highlighted below. It's classified into different phases: project planning and mobilization, whereby you look at engineering review and the risk assessment of the pipeline that we want to decommission. Then even at this commissioning, you still need to get a permit and regulatory compliance to how you want to go about the decommissioning. Then the mobilization of crew and equipment, that is at the project planning stage. At the preparation stage, you look at the shutting down of the line and isolation of lines. Then the residual fluid in the pipeline must be removed. Then the flushing of the line. Then disconnection and cutting. You cut some of the line and then you disconnect and remove from the soil. Then after removing them, excavation of buried section, lifting and staging pipe segments, transport to disposal yard, then abandonment in place where applicable. Then the next thing is to backfill and grade the line to restore it back, then erosion control and vegetation. Then the purpose of all this thing is to ensure that we are keeping the mother heads in a proper place so that our activities will not impact negatively on our environment. That is why the subject of decommissioning and proper decommissioning and abandonment must be put in place, even for both pipeline and the storage tanks. All this while I've been talking majorly on pipeline, so I move on to storage tanks now. So I'm just trying to because of my time, I will try as much as possible. So Classification of pipe storage tanks also, we use different criteria also to classify storage tanks. Now, if you are looking at classification based on shapes, we have cylindrical tanks, and then we have spherical tanks. We have cuboidal tanks. Uh, this one is an example of a cylindrical tank. You can see it is cylindrical in nature, like a cylinder. Maybe in the next page, you will see spherical tanks. These two type of tanks, this cylindrical and spherical, are used in oil and gas. Cylindrical can be used for oil, water, and the like, while spherical tanks can be used for storing gases, different for gas and NGL, natural gas liquid. Then cuboidal tanks is not applicable in oil and gas, but some people use it as overhead tank for storing water. But you just based on the classification by ship, these are the three types that we have. Then oriented, we have vertical tanks as we have in this one, is vertical. Then we have horizontal tank when it is by the side. The next page, we will see the pictures of all this. Then classification based on the type of roof. We have fixed roof, where this one is fixed roof. The roof is fixed there. And then the next one, we have floating roof, which can also be external floating. I will explain more when in the next slide. Then the last classification is based on the location. Is it above ground or underground? This one is also example of above ground storage tanks. But the one that we have in our filling station is underground storage tanks because it is put underground. So that is why we say based on location, it is above ground and underground. Okay, so now confirm that you are seeing my screen.
Yes, sir.
Yes.
Hello? I hope I'm not talking to myself.
No, we can see your screen, sir. Yes, sir.
All right, thank you, sir. Okay, so the first year, the one external, this is external floating roof. Floating roof tanks are common. You can normally in refineries and maybe some flow stations. What is the difference between floating roof tanks and a fixed roof? This one is fixed. Roof is fixed. It doesn't go up. It doesn't come down. But look at this one. As the fluid is coming into this tank, it is the fluid that will be lifting the roof of the tank up. And as you are discharging from the tank, the roof also will be going down. The question will now be, why floating roof? Why fixed roof? Floating roof tanks is complicated and it's also expensive than fixed roof tanks, but it has an enormous advantage that outweigh the cost associated to it. One of it is because of safety. In refinery, safety is paramount. So generally in oil and gas, safety is paramount, but in refinery, the level of safety in refinery is even more stringent than any other parts of any other value chain of oil and gas. Now, our HSC people will tell us that, okay, before you can talk about fire, three things must be present. A triangle, which is there must be source of ignition, which is spark. There must be what they call fuel. It can be solid fuel, it can be liquid fuel, and then there must be oxygen. Now, if we have three things, we have spark, source of ignition, we have fuel, and then we have oxygen. If you remove one leg of this triangle, there can never be fire. So the purpose of this one is that now in this type of arrangement, these floating roof tanks, we have fuel there, which is the product inside the tank. So there's no way we can isolate that. Then The only thing, and the spark can come at any point in time, you can isolate it completely. The only thing you can isolate is to ensure that there is no oxygen, no air at all, no air. If there is no air at all, there can never be fire inside this. So the purpose of floating roof tank is to ensure that no air is introduced. Even if there is a by mistake any spark, then there will not be any fire. Unlike this one now, this fixed roof tanks, you can only fill it to the top here. You can't fill it to reach the topmost of the roof. And the space between the last shell here and the roof, there will be space that will be occupied by oxygen, by air. So any little spark on this one can ignite, the fire will be ignited, and then everywhere will be burnt off. But in this floating roof, there is no room for air, and there cannot be fire. So that is why floating roof tanks is so much more desirable in any place, but it's so expensive. That is why it's somehow restricted and limited to refineries. Okay, so this one is for, the one I'm seeing here is for horizontal tanks, and it's above storage tanks, surface tank, and also horizontal tank. Then this one is a spherical tank that I mentioned earlier for storing gases and NGLs. Okay, so the standard and codes for storage tanks, we have API 650, which is welded steel tanks for oil storage. And then we have API 620, which is design and construction of large welded low pressure storage tanks. Now, the question is, what is different between 650 and 620? This one is 650 is for atmospheric, no pressure at all, atmospheric storage tanks. But 620, there is a low pressure up to like, is it for 35 or 45 PSIG. But there's no room for pressure in 650, but there is little pressure in 620. Then we have API 653, which is inspection, repair, alteration, and reconstruction of above storage tanks. Then we have European standard EN 14015, which is specification for design and manufacture of site-built vertical cylindrical tank. Then lastly, we have NFPA, which is National Fire Protection Association. These are some of the standard and codes that is being used for designing oil storage tank. So just like pipeline, storage tanks also, you can't just wake up and say, I'm building a storage tanks. There are approval gates, there are approval and permits that must be obtained before we go ahead to build a tank. So part of this is a conceptual feed, detailed engineering design, then notification of commencement of construction as well, then commissioning with approval to introduce hydrocarbon. Then also approval relating to inspection, testing, and calibration of storage tanks. After we build the tanks too, there must be approval that necessary non-destructive testing has been carried out to ascertain the integrity of the tank that has been built. The tank must be hydro tested. You fill it up with water and be checking the settlement level. And also the tank must be calibrated to ensure that you have, the volume at incremental height, at incremental volume, at incremental level. And this is what is called static measurements, to know the content of the tank at every level. So as I said, API 650 and API 620, two of them, they focus on safety and structural integrity of tank. And both the two standards cover material selection, welding, inspection, and testing. But there are still some little differences between the two. One is designed for atmospheric, which is 650, then the other one is designed for low pressure. And then in API 650, it allows for a wider range of materials, which include the carbon steel and stainless steel. But API 620, there are some stringent materials that must be used because of the pressure rating. So API 650 design tanks are good for crude oil storage and petroleum products. But API 620 is actually meant for condensate and then LPG and petrochemicals. So then lastly, welded steel tanks with a flat bottom and roof that is either fixed or floating. But for the API 620, it is always dome roof. Okay, so now what is the importance of proper design? Strict adherence to the provision of API 650, or depending if it is API 620 that is being used, must be avoided, must be observed to avoid disastrous failure. To ensure that there is no room for any failure, everything stated in the API and other sound engineering judgments must be followed to ensure that there is no failure. You can see some of the failure here some of the pictures showing the failure in tanks. You know, storage tanks is regarded as a what do they call it? Thin wall structure, thin wall, because if you compare the thickness of the plate with the diameter of the tank, you will know that it's a thin wall structure. I remember in undergraduate that they talk about a thin wall structure and a thick wall structure. Storage tanks is a thin wall structure. So see how just like maybe you hold a can of Maltina now, like you are now folding it. See, that is the kind of failure that we can see, a total collapse of tank shell, as if you just hold the can of soft drinks and then you fold it with your hand. So this is as a result of poor design construction. This one is called elephant foot buckling. You can see how this thing buckle like this. It was not this was not a design, but rather failure in the design of the tank base. And the next one is diamond buckling. You can see like a diamond. This one like a sagging at the middle. So all this failure must be avoided. So in continuation, so what are the things to be considered if we are using API 650? We consider the tank size and the capacity. Then the material selection, right material must be selected. We can't go into details now, but this is just to give overview of pipeline and storage tanks, how they are interconnected, that it is difficult to separate one from the other. Then we look at the welding requirements. Structural integrity also must be considered, and then corrosion protection of the pipe of the tank also must be put into consideration. Then the design requirements, you design for the shell, and we have three methods to design for the shell of the tank. We have shell is the one, okay, this is the head. This is the shell. I think this one is having maybe shell 1, shell 2, shell 3, 1, 2, 3, 4, 5. So you design for the shell of the tank. So we have three methods. The common method is 1-foot method. This one is so common and straightforward to use. This one, if you design with a variable design point method, is more stringent than 1-foot method, but it's also difficult to use. And the most difficult one is elasticity method. But three of them will still give you if you follow, it still give you satisfactory results. Okay, then you design for the roof, we design for the bottom, then the nozzles and fittings also we design for them. And then in conjunction with a structural or civil engineer, the foundation is also designed. Then what are the inspection and non-destructive testing carried out on storage tanks? While the construction is going on, before the actual fabrication of the tanks, the welders are to be pre-qualified by competent welding inspectors. to ensure that the welders that will work on the tank, they understand the welding procedure that they want to use, the material and the likes. Then when the proper construction has started, there will be radiographic or X-ray done on the selected joints. Then vacuum burst testing on the welding seam to ensure that they are not leaking. Then penetrant testing also must be done. Tightness testing. So some people also will do post-weld heat treatment tests to ensure that all the induced stress as a result of welding, they are normalized. Then lastly, hydro testing of the tank. Fill it up. Hydro testing is done for two reasons. Number one, to ensure that to check the settlement of the tank base and the shell. Then number two is to see if there is leakage from the wall of the tank. So it will be so obvious that when there is a leakage, you'll be able to see it. Then the calibration, we are looking at the calibration and the commissioning of the storage tanks. As I said earlier, calibration is just the science of determining the exact true volume of a containment system at every level, incremental height. So every new tank must be hydro tested and calibrated. They must be hydro tested and calibrated before it is being put to use. So as a result of calibration, a calibration chart or what we call a tank table will be generated, and that calibration chart values for 5 years. So you don't recalibrate until 5 years. The only condition that can make you to do another calibration before 5 years is maybe if you have done anything on the tank, maybe change the bottom or change the product that is to be stored or change the shell. If you have done anything that will affect the structural integrity of the tank, the calibration must be done immediately. Don't wait for the next 5 years again. So how is this calibration is done? Calibration is done in two ways. We have a wet calibration method and then dry calibration method. Dry calibration method is otherwise known as the geometrical method, while the wet calibration is known as the liquid method. And the geometrical
Excuse me, sir. I
methods
sent
are
you a chat, sir. Excuse me, sir. I sent you a chat, sir.
okay. Maybe because of my time, let me check. Yes, just a minute. Uh, okay, is it on the okay? Sorry. Is it for the time? Hello, sir.
Yes, sir. 5 minutes, sir.
Okay, I will round up now.
5 minutes. Okay.
Okay, I'm about to round up. Okay, so um these are the integrity tests to be done on the tank, visual inspection, corrosion monitoring. Then the best practices to do the regular inspection, risk assessment, training and certification of the personnel working on the tank. And for the decommissioning of oil storage tanks, the methodology, the procedure is also highlighted here for how to decommission and abandon storage tanks. Okay, so for the benefit of young engineers and maybe students and graduates alike, what are the software that can be used for pipeline and storage tanks? I put Excel as number one because I believe that Excel is the most versatile software because once you understand the rudiments of the standard, you can quickly use Excel to do the programming by yourself. Then we have some other ready-made software like Afiva PDMS for drawing. We have AutoCAD Plan 3D, apart from regular AutoCAD. We have Cesar 2, Pipeflow Expert, and ETANS. Then what are the international certifications that can be obtained for pipeline and piping system and storage tanks? We have API 1169, which is Pipeline Construction Inspector. Then we have API 1184, pipeline facility construction inspector. Then for storage tanks, we have API 653, above ground storage tanks inspector, API 510, pressure vessel inspector. So these are the certification courses that is being done by API. It's recognized globally, so but you can take it. I think it's only in Lagos that you can write the exam. Okay, so the highlight of presentation as I'm rounding up is that the pipeline is the safest mode of transportation, as I said earlier, for oil and gas, but it requires careful planning, design, and maintenance to ensure its integrity. Number two, a well-designed and well-maintained storage tank is essential for the safe and efficient storage of oil and gas. The integrity of pipeline or storage tanks is only as strong as its weakest link. So it's crucial to identify and address potential vulnerability. Then regular inspection and maintenance are key to preventing accidents and ensuring the longevity of oil and gas infrastructure. So these are the bibliography, and these are the appendices for the if you are using ASME B31.4 or B31.8. Okay, so that's the end. Thanks for listening.
Thank you so much, sir, for taking time to spill the beans on pipelines and storage tanks. So now we have the opportunity to respond to questions. Please, can you drop some virtual applause, some comments on the chat box? Let's see how engaging and how you enjoyed the lecture. Thank you so much, Engineer Olayinka Bola, PhD, for taking our time to share this knowledge with our professional members. Please, we have the time for questions now, but because of time, we will not be able to take more than 2 questions. So we are going to ask for 2 people to text their questions. If you have more questions, kindly endeavor to search his name on LinkedIn. You will see his profile, and then you can send more questions to him. But now we'll take just 2 questions. So please, who are the 2 individuals I would like to ask questions? If you want to speak, you can unmute your mic and speak, but raise your hands first. Or if you want to type it down on the chat box, you just chat it on the chat box, and then I'll read it for our speaker. Thank you very much. Okay, we have a hand raised already. Okay, sir, please go ahead. Go ahead.
Okay.
Hello.
Can I go ahead?
Yes, please.
Okay, thank you, Doctor, for a well detailed presentation. In fact, I have to reach out to Ofonono for a copy of the presentation because there are too many information that I know is quite relevant to even what I do every day. So once again, I just wish to appreciate you. But there are some aspects I just wanted to call your attention to, even as you look at the slides. It's just if you look at the PIA, the OPLL has been updated to the gas transportation pipeline license and the petroleum liquid transportation pipeline license, if I'm correct. And then just on the bulk storage again, there's the bulk petroleum liquid storage license, and then the bulk petroleum liquid storage license, just to also incorporate it into the presentation just going forward. Thank you.
Did
Those are my
you get
comments.
his comment?
Yes, thank you. Thank you so much for the comments. I really appreciate it. I actually know that there are box storage license, which is being issued by the NMDPR. But the reason why I didn't go much into that is because I felt that, okay, this one is a downstream, and then it's like I'm going through details into all those licenses. This one is mainly into the discussion mainly center on mostly on most upstream, midstream, and few parts of the downstream. But that is well noted. Thank you for that observation. Thank you, sir.
Okay. The very next person, the last question we have for today, please go ahead with your question, Salim Madawaki.
Thank you very much, sir, for that presentation. I really enjoyed it. My question is with regards to the material selection. I think you kind of touched on that, but I wasn't sure I totally got everything. So it's on the material selection for flow of sour service fluids, that's meaning H2S and CO2. So, is there a kind of reference material or guideline one can refer to?
Okay, thank you so much for the question. Yes, there are reference material. Most of these material are stated in the all these API standards, depending on the one you want to use. And then, even if it is not stated, the property is not well stated on the API, there are other guidelines that they are going to refer you to get more on it. And that is why sometimes you might also need to check the procedure guides and regulation from the regulators like AUPRC and NMDPRA. Because in a situation whereby some materials are being contested between international and local law, the local must prevail over the international. So we should not be far away from this regulator for guidance. Thank you.
Thank you, sir. Please confirm you've gotten your response, Salim.
Oh yeah, I have. Thank you very much.
Okay. Engineer Pedro, please. Go ahead, sir.
Okay, good
Thanks for
evening,
joining.
everyone.
Good evening, sir.
Thank you. Engineer Dr. Olanka. I'm from the upstream sector. So in addition to what you listed out, we also have the flow line in terms of pipeline classification. So the piping system are for the plants. The flow lines convey oil or gas from the wellhead to manifolds or to the flow station, and then after from the gathering point, which could be the manifold, or from the flow station when you are taking it to market or storage for sales, we now use pipelines. That's another way of classification that you should take note of. Thank you. In a nutshell, you missed out the flow lines.
Okay, thank you so much. That is well noted. I know, but it's just an omission. Yeah, flow lines go to the gathering manifold. From there, you lay a single line to the flow station. Yes, you are absolutely correct. Well noted.
Okay. Thank you so much for your time, sir. Thank you so much. You can see so many amazing comments on the chat box. Of course, the slides will be sent to you. Engineer Lainka, please, you kindly appeal that you share the slides to our program's chair so that we can have the slides and share to all of the amazing participants. I believe
No
we may want
issue,
to
sir.
adjust it.
It
Okay.
will be shared.
Okay, thank you. So many comments. Sorry, Mohammed Musad, we cannot permit further questions. If you have questions, kindly appeal that you look for and search Engineer Olayinka's. His on the screen. You can take a screenshot of his phone number. That's on WhatsApp, I believe. His email address is also on the screen. Please take a screenshot of those details and reach out to him privately. We're short of time and we are wrapping up right now. So, ladies and gentlemen, thank you, sir. Engineer Line, can you stop sharing your screen, please? Thank you. Thank you so much, sir, for that amazing presentation. Thank you so much, sir, for sharing your screen. So this is SP Abuja section, and okay. So we wrap up the event in very few seconds. Yes, you would get copies of the slides immediately. We have it from the speaker. I believe you might want to. Engineer, please stop sharing your screen, sir. Thank you. Thank you so much. Let's share a little information about SP Abuja. Immediately, our speaker sends his slides to us. We would make it available to all of those who are requesting for it. Thank you. So, ladies and gentlemen, of course, we are advising you that if you're not a registered member of SPE, this is the time to register. Of course, there are several professional and student member benefits being a member of SPE Abuja. A new membership fee is at 6,500 naira only, and then to renew is about 69,500 naira. Please take a screenshot of the phone number on your screen, which is the number of our membership chair, so that he can assist you and guide you on joining. If you want to renew, the account details is also on the screen. Please do well by taking a screenshot so I can make payment for your renewal. We are live on all social media platforms: Facebook, Instagram, YouTube, Twitter, now called X, of course, LinkedIn as well. Please visit those pages. You will see all of our future events and, of course, past events. On YouTube, this event and past events has been live streamed on YouTube. You can go back and refresh your memories and, of course, learn from our distinguished professionals. We have a distinguished lecturer program coming up on the 29th of October 2025 by 4:30 p.m. Of course, the venue will be sent to all registered participants. So we appeal that you visit the link, visit our LinkedIn page, check I have the link, and register. And of course, you will get the venue for this event. 29th October, and of course the theme is CO2 sequestration, a practical insight for decarbonization success. And we'll have Ahmed Kanifa, Dr. Ahmed Kanifa, the SDP manager for Petronas in Malaysia, visiting Nigeria, and of course Abuja section, one of the sections in Nigeria that will enjoy his presence. We switch gears immediately right now to our closing remark. We'd like to hear from Professor Kafaya Tadeni, our program's chair. Over to you, ma'am, for your remarks.
Good evening once again, and thank you everyone on the call. We've been listening to a very detailed presentation by Engineer Dr. Agbola for about 52 minutes, and it was very detailed, and I want to believe each and everyone on the call has something to take home, has learned something from this presentation. And I want to use this opportunity to thank our facilitator for the time. I know what it takes preparing for such time and the effort you put into it. We do sincerely appreciate all of that, and we value the time you have spent sharing what you know. At the start of your presentation, you made mention that there are professionals above you, at par with you, and below. And I can see from the flow of questions, that means you carried everybody along. The more experienced ones were telling you you didn't cover this area, and that's how a presentation should be: very interactive. Everybody has a takeaway. So thank you so much. And then to Abuja section chair, section board members, and everyone on the call, thank you so much for your time, and see you again next month. Thank you.
Thank you. Thank you. Thank you so much.
You,
Thank you, ma'am. Ladies and gentlemen, we come to the end of our event. Please, we ask that you turn on your video cameras. Let's see your beautiful faces. Turn on your video cameras. Let's have a screenshot of your beautiful faces, please. Thank you.
So Dr. Agbola, I'll link up with you shortly after this session.